According to the National Electrical Code, a grounding bushing is indeed required on a 480-volt motor installation even if the ground wire is pulled in the sealtite from the disconnect and even if reducing washers are used. The primary reason for this requirement is to ensure electrical safety and proper grounding of metal raceways and enclosures. The National Electrical Code mandates that all metal raceways and enclosures that house electrical equipment must be effectively grounded. The reason behind this code is that metal raceways and enclosures have the potential to become energized during an electrical fault. If these components are not properly grounded, they can pose a significant shock hazard to individuals who may come into contact with them. A grounding bushing serves as a critical component in providing a low impedance path to ground for both the raceway and the enclosure. This low impedance path is essential for safely discharging any fault current to ground, thereby minimizing the risk of electrical shock. The presence of a ground wire pulled through the sealtite from the disconnect does not eliminate the necessity of a grounding bushing. The grounding bushing offers a more dependable and robust connection to ground compared to the sealtite alone. This enhanced connection is particularly important in ensuring the safety and reliability of the grounding system. Reducing washers are often used to adapt the size of the grounding bushing, allowing it to properly fit within the sealtite fitting. These washers are designed to maintain the electrical continuity and grounding effectiveness of the connection. Therefore, the use of reducing washers does not compromise or diminish the functionality of the grounding bushing. It's crucial to consider several factors related to grounding bushings and their proper installation. Firstly, the selection of the correct size of the grounding bushing is important. The bushing should be appropriately sized for the conduit or fitting to ensure secure and effective connection. Secondly, the grounding bushing needs to be properly installed. This often involves cleaning the surfaces of the conduit and enclosure to remove any dirt, rust, or corrosion that could impede electrical conductivity. A conductive anti-oxidation compound may be applied to enhance the connection. Thirdly, the torque specification for the grounding bushing's set screw or connector should be adhered to. Proper torque ensures a tight and reliable connection without damaging the component. Fourthly, regular inspection of the grounding bushing and its connection is recommended. This involves checking for any signs of corrosion, looseness, or damage. Periodic maintenance can help ensure the long-term effectiveness of the grounding system. Additionally, consider the material compatibility of the grounding bushing with the conduit and enclosure. Using dissimilar metals can lead to galvanic corrosion, which can degrade the connection over time. It's generally recommended to use grounding bushings made of similar materials to the conduit and enclosure to minimize this risk. Furthermore, when working with rigid metal conduit, it is important to ensure that the conduit is properly reamed after cutting. Reaming removes any sharp edges or burrs that could damage the insulation of the conductors and compromise the grounding path. The National Electrical Code provides detailed guidelines and requirements for grounding and bonding electrical systems. These requirements are outlined in Article 250 of the Code. It is essential for electrical professionals to be familiar with and adhere to these requirements to ensure the safety and compliance of electrical installations. In addition to the grounding bushing, other grounding and bonding components may be required to ensure a complete and effective grounding system. These components can include grounding electrodes, bonding jumpers, and equipment grounding conductors. The specific requirements for these components will vary depending on the size and type of electrical system. The equipment grounding conductor plays a crucial role in providing a low impedance path for fault current to return to the source. This low impedance path helps to quickly trip the circuit breaker or fuse, interrupting the flow of current and minimizing the risk of electrical shock or fire. The size of the equipment grounding conductor is determined by the size of the overcurrent protection device protecting the circuit. The National Electrical Code provides tables that specify the minimum size of the equipment grounding conductor based on the ampere rating of the overcurrent device. When installing grounding and bonding components, it is important to follow the manufacturer's instructions and use the correct tools and techniques. Improper installation can compromise the effectiveness of the grounding system and create a safety hazard. Regular testing of the grounding system is also recommended to verify its integrity and ensure that it is functioning properly. Grounding resistance measurements can be taken to assess the effectiveness of the grounding electrodes. Continuity tests can be performed to verify the integrity of the grounding conductors and connections. The National Electrical Code also addresses the issue of objectionable current. Objectionable current is current that flows on grounding conductors or metal enclosures that are not intended to carry current under normal conditions. Objectionable current can be caused by a variety of factors, including improper wiring, crown loops, and unbalanced loads. The National Electrical Code provides guidelines for identifying and mitigating objectionable current. These guidelines include isolating grounding conductors, using ground fault circuit interrupters, and balancing loads. In some cases, it may be necessary to install a separate grounding electrode system to address objectionable current. A separate grounding electrode system can provide a dedicated path for fault current to return to the source, minimizing the amount of current that flows on other grounding conductors or metal enclosures. When installing a separate grounding electrode system, it is important to ensure that it is properly bonded to the main grounding electrode system. Bonding ensures that the two grounding electrode systems are at the same potential, minimizing the risk of electrical shock or fire. The National Electrical Code also addresses the issue of transient voltage surge suppression. Transient voltage surges are brief spikes in voltage that can damage electrical equipment. Transient voltage surges can be caused by lightning strikes, switching operations, and other factors. The National Electrical Code recommends the use of surge protective devices to protect electrical equipment from transient voltage surges. Surge protective devices are designed to divert surge current to ground, preventing it from damaging sensitive electronic components. When selecting surge protective devices, it is important to consider the voltage rating, surge current capacity, and clamping voltage. The voltage rating should be appropriate for the electrical system being protected. The surge current capacity should be sufficient to handle the expected surge current. The clamping voltage should be low enough to protect the electrical equipment from damage. Surge protective devices should be installed in accordance with the manufacturer's instructions and the National Electrical Code. It is also important to regularly inspect surge protective devices to ensure that they are functioning properly. Some surge protective devices have indicator lights that show whether they are still providing protection. If the indicator light is off, the surge protective device should be replaced. In summary, ensuring proper grounding and bonding is paramount for electrical safety. Even with the ground wire pulled in the sealtite from the disconnect and the use of reducing washers, a grounding bushing remains a critical component in a 480-volt motor installation. Adhering to the National Electrical Code requirements, selecting appropriate components, and performing regular inspections are all essential steps in maintaining a safe and reliable electrical system. Remember to always consult with a qualified electrician for any electrical work to ensure compliance with local codes and regulations.